So the Viking essentially is all back together, and I've been, so I put all the seats and stuff in it. Engine oil's gone in, coolant's gone in, there were no leaks. Started fine, cleaned the air filter up, put the oil on, you saw that on the previous video. And because, well, as with any vehicle really, you've got to test to make sure that everything's okay. Now remember, this vehicle came in with an overheating problem, so I was focusing on the cooling system. Took the vehicle around the paddock, up and down some hills. I was trying to get it to the point where the cooling fan on the radiator would energize it, be activated by the relay, by the thermo switch on the engine, and the fan would then cool the radiator down and the whole thing will be working as it should do. It turns out, driving around the paddock, that the red overheating warning lamp, it's not really drastically overheating, it's just getting close, they don't have a temperature gauge as such, that light started to flash. It wasn't on permanently, but that tells me there's a fault. They shouldn't get, it is quite a warm day today, but it shouldn't get that hot. So I parked up, checked that the cooling fan was operating, and it wasn't. So under further investigation, it turns out that the cooling fan, which is sat behind the radiator, and I'll show you in a second, is essentially seized up. Now it could be a seizure inside the motor, or it could be just mud, a buildup of mud and debris, and we've seen a lot of that inside the floor pan, causing the blades to jam. So we'll remove the fan, check that it works. If it does, then obviously we're all good, we can clean all the mud out and stick it back in. If it doesn't work, and we can also check that it's getting a 12 volt feed once the engine is up to the temperature that would trigger that fan to work, so we can run the engine up, leave it running until we see a 12 volt supply going to the wires that feed the fan. To check that side of the circuit, that's going to check the fuse, which I've already checked visually anyway. It's going to check all the wiring in the circuit, it's going to check the relays working properly, and it's going to check that the thermo switch is working properly. So it's going to check all that side of things. But from what I can tell at the moment, just by trying to turn the fan blades, they are seized. Now it hasn't blown the fuse, which surprises me, which means there may be another fault. It could be that the reason why all that mud's built up in there is because the fan hasn't been working and the mud's just been building up over time. So it could be a fault of the thermo switch, it could be the relay, there could be a broken wire somewhere. So we have to get down to the bottom of this and get it fixed. There's no way the vehicle can go back in this condition. And this could have been, who knows, this could have been the primary failure. Customer thinks it's the thermostat. I don't have access to the old thermostat, I can't test it, I just don't know. But it may well all have been down to the fact that this fan, this cooling fan, has stopped working, which has caused all these problems with the engine and the warping of the head and the failed head gasket and all that kind of stuff. Because they just kept driving it. It is one of the problems when you only have a warning light. Drivers tend to ignore warning lights. If you have a temperature gauge, a proper temperature gauge, an analog one with a needle that goes up into the heifer high, the H, you know, some people tend to stop when the needle starts to bend against the little pin that's the stop on there. Okay, we know that some keep going until the steam out of the bonnet and everything seizes up and the car will never start again. But if you have a gauge, there's far more chance of the vehicle operator taking into account the information on that gauge. If you have just a little tiny warning light, and some cars have this now, they have a blue little thermometer symbol for a cold engine when it's warming up, and they have a little red thermometer when it's overheating. They've done away with the temperature gauge. Why? Temperature gauges are great. The gauges, remember the old sports cars in the 60s, all these gauges, oil pressure and all that kind of stuff? Bring them back. It's important. We need to know what's going on under the bonnet. Please. Okay, so I'm going to dig that fan out from behind the radiator. I'm hoping not to have to drain the coolant again. Really, I don't want to do that. Okay, so here we go. Okay, so the cooling fan, well, the radiator is at the front of the vehicle, as you probably gathered, and the cooling fan is, it's a bit warm down here, but is located here. And this is me trying to turn those blades, and they're not having any of it. I can't really see a lot of obstructions, but we'll pull it out and have a look at it. Either the motor's failed and jammed up inside, or there's debris jamming the fins or the blades of that fan against the cowling. So we'll have a look and see what we find. Back. Yes, I'd not be using a windy gun or a rattle gun, but the air compressor's not installed yet. That's the job after we fix the Viking. Okay, so just to gain some access, I'm going to remove this coil over shock. So 14 and 17. We'll get those out, and then we've got a bit more access. I'm really hoping not to have to drain the coolant, but the more I look at it, the more it looks like I'm going to have to do that. Okay. Right. You can see what's going on now, can't you? Easy. Okay, so the fan itself, the bolts are inaccessible, so you've got to remove the whole cowl, which is these 4 bolts here, 2 mils. I'm just taking it a bit easy because this radiator is still reasonably hot. I really want to get that fan out and test it and see if we can get it working again. Because if I have to order a new one, it could be in Japan. It could be in 2 weeks. And that is going to be a pain. Because you can guarantee the motor's not serviceable. It'll be a sealed motor. Okay, so you just see me just remove these 2 bolts. I'm just going to pull the fan back to one side and have a look inside. And you can see it's not too bad. It's not too bad at all. So that feels to me like the motor's given up. Really hard to turn. So anyway, we'll pull it out and we'll test it. Right, let's get these 2 bolts out. I'm not going to pull the shock out as well. That was just to help get the fan out one side of the vehicle. Might need a spanner for that top one though. There we go. Right, back to the other side, I think. Okay, that's the cooling fan loose. There really is. Ooh, I wonder if we could undo the radiator mount, take the radiator and the fan out, because there's quite a lot of movement on these pipes. Yeah, let's give that a go. I'll just remove the top mount for the radiator. It's got the horn on there as well, so I just disconnected that. Now, hopefully, if it's not too hot, I can lift the radiator up. I can bring the radiator over this side. That'll bring the fan with it. Okay, I'm winning. I'm getting there. I reckon I can get the fan out without draining the coolant. So, underneath here, or should I say behind here, are the wires that feed the fan the current for it to run. So I've got to disconnect that. And it's pretty tucked away. But I reckon we can get there. Everything's possible. There was me thinking this vehicle would be finished today. How wrong you can be, eh? Right. Coolant tank. That's just a breather up there, so we can get rid of that. There we go. Okay. Stick that up there out of the way. That way it can't leak. That's better. Bingo. Okay, should now be able to withdraw that fan. Should just give us enough now. So delicate radiators. Yeah, it's not looking easy, is it? Get enough of a gap. There we go. That's what we needed. Turn off. Bingo. One fan, one cooling system, unaffected. Pop that back in there for a bit. There we go. That was tight, but you can see the fan spinning better now. See if we can get it to work on the bench. There we go. Okay, so we've got this the circuit set up. I've put an ammeter in circuit 2, so you'll be able to see what that's going to read. See that? Yeah, there you go. So basically, when I complete the circuit with this Pro, sorry, I'm not in the picture now, but that's the way it is. You'll see an amperage draw. Now, I've checked the battery; it's fully charged. Plenty of juice in the battery, and we're getting 0.2. Now, it is trying. You can see every now and again it'll twitch. Yeah, look, it's just to say twitching now. It's a sealed motor. We can't get in there, we can't clean the brushes up. Oh, there you go. It's not a happy bunny. So it's going to need a new fan. And that's probably down to water ingress that's caused that fan to fail. What are we on now? 4. Can you still see that? You can, can't you? Cool. Okay. So maybe if it will fire up we can get it to run, but hey, this is a really important component on the vehicle. This is potentially what caused the failure of the engine to start off with. We're not entirely sure. It could be this, it could be the thermostat. There's no way I would risk putting this fan back on the vehicle again. So I'm going to give my parts guy at Yamaha a call very shortly, and I'm going to order a new fan. So we've tested the fan and it's failed. It is trying to operate, but I think either it's burnt out or there's corrosion on the brushes or the commutator. Corrosion on the commutator or the brushes have worn out, which is unlikely for such a young vehicle. But if the thermostat's failed, then this fan could have been operating all the time rather than just intermittently. So it could have burnt the motor out. So it's amazing how one fault can cause other faults on the vehicle. Either that or the fan failed, and that's what caused the head gasket to fail. You know, we just don't know. I wasn't there to test it as it developed. But we do know that this fan doesn't work. We now need to go onto the vehicle, run the vehicle up again, get it warm, get it hot, get it to the point where the relay should be tripped to energize the fan, and we need to make sure we're getting 12 volts at that plug, which is what the fan connects to, what feeds the fan on that particular circuit. If we're not, then there's another fault on the vehicle, and we need to look further. If we're getting the 12 volts, then that's great, no problems at all. All we need to do is fit a new fan and she should be working fine. Okay, so just out of interest, whilst the old Viking's been warming up, I decided to remove the fan, and I'm going to take the motor apart because this is scrap. We've ordered a new one, and I noticed water coming out of the drain. That's a breather pipe, and that's in the down position when it's on the vehicle, and we've got water. So this fan is full of water basically, so we'll pull it apart and we'll see what damage that water's been done. Now I've also ordered, like I said, I've ordered a new one of these through Yamaha, and it turns out they're on back order, which means there's usually quite a high demand and they've run out of local stock. There's 5 on back order at the moment, which tells me that maybe these fans aren't actually quite as good as they should be. An 18-month-old vehicle shouldn't have the fan failing, and they certainly shouldn't be getting water inside the motor. So come on Yamaha, let's have an upgrade. Let's make these better so they last longer. Just out of interest to let you know, these are over $400 for a new one. So I'd be pretty upset if I was buying a new one every 18 months. They should last a lot longer than that, you know, especially when you've got to pressure wash these vehicles on a regular basis if they're working in a bad environment. So this needs to change. This needs to be better. Right, so because it's scrap and there's no way it can go back together, I've had to drill out 3 rivets around the outside and grind off these 2 center rivets here. The whole fan is the two halves are silicon together. You can see the sealant around here. So they've obviously had a problem of water ingress when they were building these fans for Yamaha. These aren't made by Yamaha. These are bought in, obviously. Most parts are. So getting it split is going to be fun because, of course, it's sort of glued. Now, my plan of attack is to get rid of this drain and then use that aperture, that hole, as a leverage point. It's usually about this time that I stab myself. There we go. That's what I want rid of. Get that out. Right, now we can get a decent sized screwdriver there and just twist it open. Hopefully. This might be big enough. Oh, there we go, look at that. Professional bodger. Ow, skin, right. Okay. So, first hand. Let's bring the old camera a bit closer for you. Okay, sorry about the tripod, really bad, but you can see now firsthand inside that motor there's water. Now, water doesn't go too well. Now you've got the little tiny brushes down here, and God, they're tiny. Look at these. That one's working, that one's seized, that one's seized, that one's working. So, you know, the condition of the commutator, which is here, is pretty bad. That's the bit that spins, by the way, that's connected to the fan. So if you look at this commutator here, like you can see there's a lot of corrosion on there. Very, very high resistance. In addition to that, the rear bearing, oh yeah, the rear bearing's shot. So that water that's got in there has corroded that bearing, and that's probably another reason why it wouldn't turn. So all in all, these fans are not waterproof at all, and it only takes the smallest amount of water to get in there for it to cause some pretty serious damage. In addition, in all honesty, these brushes are tiny. They should be bigger than that. They're just not up to the job. Sorry, Yamaha. I know you can do better, so do better. As it turns out, actually, I didn't need to grind those off. Hey, because all that's doing is holding the brush pack. Right, back to the vehicle. These are the two wires that feed the fan. So we're going to test the motor, but also we need to check we're getting 12 volt supply to here when the engine is up to temperature and needs the fan to turn on. So we need to make sure we're getting the feed from the relay at this point here. Right, into the workshop, let's go and test that fan. Okay, so I've just popped the radiator back into its normal position again, so it's secure and it's not going to get damaged. They are quite delicate, and the last thing we want to do is put a hole in the radiator. What we've done, put the shock back into the vehicle now, is standalone, tucked away all the breather pipes and stuff from the front diff and things. And around on this side, because we have to order a new fan, I've snipped off the wiring off the fan and rigged up a little test light. So when we get 12 volts, rather than using a multimeter, a bit different, I've rigged up a 12 volt test light, which is an old brake light assembly bulb and bits, so both filaments should light up nice and bright. So we're going to start the engine up, leave it to warm through. I might have to rev it for a while. I won't leave the camera rolling for the whole duration. Once it's close to temperature, I'll film again, and we should see that light ping on before the engine hot warning lamp comes on the dashboard. That'll tell us that the circuitry that controls the cooling fan is all working correctly. Right, let's do that. Okay, so the bulb did come on before the overheating warning light. I've turned the engine off, allowed it to cool just a little bit. I'm going to restart it now, and we're just going to double check that bulb does come on, which tells us we've got a 12 volt feed which would be going to the fan and energizing the fan. And that tells us that the circuit, the relay, the sensor, all that kind of gubbins is all working correctly on the vehicle. So when the new fan arrives, we can just plug it in and everything should work fine. So there you go, we have a 12 volt feed that would be powering the fan. So the vehicle stuff is fine. We'll just have a quick look inside and make sure that the warning light's not on. Now the overheating warning light is in this part of the dash here, and it's still off. So that's good, that's great news. All we need now is a new fan. Come on Yamaha, I need that sharpish. Okay, the day is coming to an end. We put the engine in the Viking, and during the road test, or should I say paddock test, I was checking to make sure that the cooling system, amongst other things, was all working correctly. And it turns out that it wasn't. The cooling fan on the radiator wasn't firing up before the engine overheat warning lamp, the red warning lamp on the dashboard, came on. Upon further inspection, we found that the circuit on the vehicle, the cooling fan circuits, that's the relay, the sensor and all the wiring and stuff, the fuse, was all working fine. We did the bulb test, test light test on there, and you've seen that, and that's all working great. So the problem was the fan itself, and as you saw previously, I took the fan motor apart. Now these are a sealed unit, there's no way I'm going to put this back together again, it's scrap. We found all the problems inside the fan relating to water ingress. So whether they've been pressure washing in the wrong place, or these are just crap, I don't know. I mean, they look pretty flimsy and nasty on the inside. I wouldn't be happy having this kind of thing on my vehicle that I'd spent $24,000 on. Golly. So I've ordered a new fan, and the fan will be here when Yamaha has stock. They have no stock because these are failing all over the place and everybody's having to buy them. There's going to be another delay in getting this vehicle to the customer, which I'm really quite disappointed about. Yes, maybe I could have tested the fan when the vehicle first came in. Hindsight is a wonderful thing. Yeah. Such is life, you know. There's lots of other stuff. We haven't got the brake pipe yet anyway, so at the moment we've not delayed the repair of the vehicle in any way. It really is down to Yamaha now to provide a fan. If it's going to be more than a week or so, then I might be able to twist the dealer's arm to borrow one off a new vehicle, and then they can fit the new one when it comes in. But we'll see. So there you go. The Yamaha Viking 2013 saga continues. It's given me lots and lots of videos for the channel though, which is great. We're finding all sorts of problems. I mean, I'm not saying they're a bad vehicle, they're not. They, you know, overall, they're an amazing machine. I mean, driving around the paddock, up some 1-in-1 slopes, through some gullies, they perform fantastically well. And this one's had a hard life. It's worked very hard, 9,000 Ks in the first 18 months. It's pretty good going. But, you know, there's just the odd component that really isn't up to spec, and I think this fan, that's one of them. They should source better quality fans. So there you go. That's about it really. I can go have a shower, have a beer, chill out, you know, hit town, who knows. Well, I hope you've enjoyed watching this 20th, 19th, 18th, I don't know, video on the channel. I've certainly enjoyed doing it. It's good fun finding faults and fixing them. I'm very relieved, pleased that the Viking engine is finally back together again. Once all the parts turned up, it seems to be running really, really well. Yeah, so my name's Andy Young. I am one of the automotive lecturers down at Unitec in Auckland, New Zealand, and I produce these videos to help my students through the year so that they can see me in a working environment and see lots of real life scenarios and how we go about fault diagnosing and repairing and checking that we've repaired it properly. So there you go. Cheers, over and out.